We're now on 7.4 because we did 2 and 3 were like the sections combined that we did properties of powers, which was kind of like a review. And so this one is going to also have some powers in it, but it's also going to talk about some money and something called compound interest. So what is it? What is compound interest, and how does it affect your money? All right, example 1. Before we get into it, there's going to be eventually like a little formula we're going to use, but we're just going to go through this together, just kind of thinking about how you'd solve this in real life. So suppose you made $2,000 this summer by cutting grass. You decide to put that money into a bank with an interest rate of 5% per year, which, by the way, would be a lot of money. The interest is added to the total at the end of every year. How much money would you have at the end of your first year? So this is also going to take you through the steps on how to do that between A and B here. So what we're going to first do is we're going to calculate what 5% is of 2,000. Now, if you remember how to deal with percentages, one way to change this to a decimal is to do one of two things. The long way is to take the percent, and 5% means it's 5 out of 100. So you could divide that. Or you could just memorize a little trick that you would move the decimal point over from 5 2 times. Either way, you get the same answer. So 5% is really 5 divided by 100, or 0.05. 0.05. So then how would we do that? If we have 5% of 2,000, we would take 0.05. Usually this word of tells you to multiply things together. We're going to do 0.05 times 2,000. So I'll go down here. We'll do $2,000 times 0.05. And this will tell us how much interest we have that the bank's going to give us. So take 2,000 times 0.05, and that will be $100. So that's how much they would give us in interest. Okay, part B. What is the total amount of money in your account at the end of the first year? So you put $2,000 in there, and you just let it sit. By the end of that year, the bank is going to give you $100 in interest on that $2,000. So total, we will have our $2,000 that was sitting in there, we didn't touch, plus the interest, which was $100. So we would have $2,100. So that would be how much is in the account at the end of that first year, which is nice. I mean, if you were able to actually put that money and set it aside and not use it, you would just gain $100. How much money would you have at the end of the second year? Okay, so now that we have $2,100 in there, we're going to use that as our new amount to take 5% of. So we're not using 2,000 anymore because we don't have that much money. We have a little bit more in there now. So if we let it in there again for another year, we would take 2,100 times that 0.05. And we're going to get even more money this time. So that is $105. So that would be our interest. And we would then add that to our old total from the year before, 2,100. So this would be 2,100 plus 105. So now we're up to $2,205. This would be after 2 years. And you can keep going, right? But the nice thing is this interest thing, which is like money the bank is giving you for letting it sit there. That's what interest is. If you're gaining interest from a bank, you're just basically getting money for letting their money sit there and, having it in the bank. And then over time, it will just start to grow. And you end up getting interest on top of your interest. So they gave us $100, but that was included in the next time that they were going to give us more interest. So it's interest on top of interest. So you just keep gaining more and more money. So there is actually a formula for this. We're going to go over what this is. There's a very basic formula for annual compound interest, which annual just means per year, like right, once per year. Annual just means, once per year. So we have this formula. We have A equals P, and then in parentheses, we have 1 plus R to the T power. So let's talk about what all this stuff means. A is going to be how much money you have in the account, the total amount of money in the account. So like what we calculated was after 2 years, we had $2,205. P stands for the word principal. I don't know if you've ever heard that word before relating with money, but if you don't understand what that means, it just means it's your initial deposit. So in our case, we deposited $2,000 from the cutting the grass. R, that's up here. Oh, there should be a lowercase here. R is your rate, how much interest rate you're getting. And it has to be in decimal form. So you got to change it from your percentage to your decimal, which is what we did to 5%. Change it to 0.05. Back here, 0.05. And the last one is T. Specifically, this is going to be how much time you leave it in the account, and it has to be in years. And the last one, we looked at 2 years, so you would put a 2 in the exponent there. Okay, so we're going to be calculating the total amount of money in the account, but they will give us the rest of these numbers, P, R, and T. Example 2, if Bill deposits $5,000 into a mutual fund and receives a 9% interest, oh, that's pretty high, over the next 3 years, what would be the total amount of money in the account? So we don't have to go through the calculation every single time. Like if you go back here, we did it for 1 year, then we had to do it for 2 years, and had to keep adding on because it changes every time. So now we can just use this formula. So I'm going to go ahead and write it out first. A equals P times 1 plus R to the T power. Okay, so let's identify all the numbers we have here. $5,000 is how much we deposit. So if you go back here, initial deposit, principal is $5,000. So we're going to put P there, principal. 9% is your interest rate. So we're going to change this to a decimal. If you move that over 2 times, that would be a 0.09. All right, and then what else do we need? We have principal, we have our rate, we just need our time. Over the next 3 years, so T is going to be 3. This is R. And what's the total amount of money? That's A. We're going to find what A is. So let's plug in the numbers. A equals our principal, 5,000, times 1 plus our rate, which is be 0.09, and then raised to the third power, because that's how many years it takes. So we're going to put this in your calculator, or if you use your phone calculator, doesn't matter. You're going to add these two numbers together first. You got to do PEMDAS. Do parentheses first, then cube it to the third power, then multiply by 5,000 at the very end. Or if you have a graphing calculator at school, you can just put the whole thing in at once. But if we add this together, we get 1.09 to the third. Raise that to the third power first, and then multiply by 5,000. So I'll just put the final answer down here. So we would expect this to be more than $5,000 because we're getting interest on that. So I'm going to do 1.09 to the third power, which is like 1.295. I'll keep all those decimals and multiply by 5,000. So I get about $6,475. And this is money, so we'll round to 2 decimal places, about 1.4 or 1.5 if you round up. So if you look at that, we started with 5,000, and within a matter of 3 years of letting it sit there, we got an extra, what? Almost $1,500. Not terrible. We're going to do one more. Example 3. Mark puts some money into a savings account with an annual rate of 5%. If he withdrew his money today, he would receive $6,876.05. How much money did he initially deposit 17 years ago? Okay, so let's go through our formula. A equals P times 1 plus R to the T power here. And what do we have? 17 years ago, so that's our time, T. It's a long time. our annual rate, 5%, we're going to change that to 0.05 like we had before. That's our R value. So we have our R, we have our T. What else do they give us? What's this number for here? If he withdrew his money today, he would receive this. This is the amount of money he has currently. So this is the total amount of money in his account. That's A. What we don't know is P. We don't know the initial amount he put, which actually it asked it in the question. How much money did he initially deposit? We don't know P. So we have to solve for it. All right, let's plug in the numbers. We have 6,876.05 equals P times 1 plus our rate, 0.05 to the 17th power. This might get a little bit ugly on the cell phone here, so I don't know. I don't know if I'll be able to finish it on the cell phone. You might have to do it on a graphing calculator. So what we're going to do is we're going to just finish this side here by combining the 1 and the 0.05, and raise it to the 17th power. So let's see what we get there. So you get 1.05. We got to raise it to the 17th power. So on my phone here, I got 2. Oh, I'm sorry, I didn't mean to put P equals. Equals on the wrong side here. 2.29. So let's round that up to 2.3. So we'll do times 2.3. That's what this whole thing here is. I did 1.05 to the 17th power. And then over here we have this still is 6,876.05. So now to solve this equation, we have multiplication between these two things here. To get P by itself, we have to divide by the 2.3. And let's see what we get as our principal. 6,876.05 divided by 2.3. So I got about 2,989.5. Yeah, we'll round that up to 5.9. So he started with about $3,000, and now he has over doubled the amount he started with. Mark started with about $3,000, and now he has almost close to $7,000. So we found the initial deposit. So there are a couple huddle problems for you to try. 3 problems there. And then after that, we're going to go to a new formula that's going to take into account something else. It looks a little bit uglier, but it's not that bad. And then we'll do only one example. All right, nice. So we'll be done. All right, so here's the new one. General compound interest formula. So this has all the same letters in it, except there's one new one. So it even says it on here. A, P, R, and T all mean the same as before. But we have a new one in here. We have a little n that's being divided here. And we also see that same letter up here in the exponent with the T. So n is our new variable. What's it stand for? It's the number of times the account is compounded during a year. Now we got to explain what compounded means. So what this means is sometimes they will actually do the calculation to give you the interest more than just one time in that year. Compounding means it's how many times they do that calculation. So sometimes they do it, 2 times a year or 4 times a year or every single month, which would be 12 times in a year. So that can also affect how much money you get. The more times they do it, the more money you get. Because again, you keep building interest upon interest. So we're going to try a very basic example talking about different values for n in each one of these problems. See how it changes things. Example 4, suppose $10,000 is placed into an account that pays interest at a rate of 12%. How much will be earned in the account in the first year if the interest is compounded as indicated? So let's talk about some numbers that we know. 10,000 is put into the account, so that's going to be your P value. Interest rate is 12%. If we move that over 2 times, that would be 0.12. That's your interest rate, so R. How much will be in the account after the first year? So our T value is going to be 1. So that takes care of everything over this side except for N. And that's what we're going to change. We're going to put an N value in here and then get the A value out. So annually, if something happens annually, it happens one time in that year. Let's go ahead and fill these ones out first. Semi-annually means it happens 2 times a year. There might be some sales that you've seen from different stores. They do semi-annual sales. That means it happens twice in a year. Remember, it's the number of times it happens per year. Quarterly means it happens every 3 months. So quarterly, if you think about the word quarter and how many it takes to make up $1, it's 4 times in a year. So let's go ahead and set this up using the new formula. It's A equals, if you need to go back and look at it, you can, P, which is $10,000, times 1 plus R divided by N. Our rate is 0.12. In this case, our N is 1. And that gets raised to 1 times 1, right? Because the power is N times T. Should probably erase that a little bit. N times T, and that would be 1 times 1. Again, you have to do this whole parentheses first. You would divide by 1, add the 1 here, and then raise to the power of 1, multiply by 10,000. So I'm going to go ahead and do that and see what we get. Looks like I get 11,200. So make sure you can do that as well in your calculator or phone. All right, so that's if it happened one time in the first year. We're going to keep a lot of the numbers the same. We're only going to change the N value. So everything else is going to be copied over. So we have A equals same amount of money. We're just going to see what happens if they do it more than once a year. So we have 1 plus 0.12 over 2 raised to the 2 times 1 again. Okay, so now I'm going to have something a little different. We're going to do 0.12 divided by 2, which is 0.06. Add that to 1, 1.06. Now we have to raise that to the second power. So right now, I just did everything in the parentheses plus the power, and I got 1.1236. I'm just going to write them all out. So we're going to multiply that by 10,000. Which is 11,236. So you can see it's growing a little bit. Not a lot, but it gave us an extra $36 just for doing it a second time that year. All right, quarterly, we'll see this go up a little bit more. A equals 10,000, same idea. Plug in the same numbers, 0.12, but now we're dividing by 4, and the exponent would be 4 times 1. So if I divide by 4, I get 0.03, add the 1, 1.03. Then I have to raise that to the fourth power. 1.1255. So I'm going to take that whole digit. It's like 1.125508881. It's best to use as many digits as you can. Multiply that by 10,000, and I get 11,255.08. It actually could be rounded up to 0.09. So again, we're getting even more money from the one time we do it a year. By doing it 4 times, we go from 36 to 55. Still 11,200, but we're just getting some extra money by them calculating it more times in a year, which is not bad. All right, part D. How much money would be in the account in 6 years if the interest is compounded quarterly? So now they're changing some of the numbers for us. Now we're going to do T of 6 years. We still have $10,000 in the account, and the interest is staying the same, I guess. So what's the difference here? We're going to have $10,000, and then times 1 plus our rate, 0.12. I assume it's the same. Compounded quarterly means we're going to do it 4 times in a year. That's your N value. So we're going to divide by 4, and we're going to raise it to the 4 times 6 years, so 6. So that exponent will be 24 now. Again, I'm going to put the whole thing into the calculator at once. So 0.12 divided by 4, 0.03, add 1. Now I got to raise it to the 24th power, which is like 2.03279, blah, blah, blah. Take that number, times it by the 10,000, and after 6 years, we're going to have $20,327.94. Yeah. It takes 6 years, but we over doubled our amount of money. Not bad. All right, the last part, and then you'll have some huddle problems doing your own. We'll be finished. How much money would be in the account in 10 years, so that's your new t value, if the interest is compounded semi-annually? So semi-annually means, if you go back, 2 times in a year. Whoops. So we're going to do n value of 2. Everything else is the same again. So A equals $10,000 we're putting in the account. 1 plus our interest rate, which I think was, 0.12 again. We're dividing this by 2 semi-annually. But then the power here is going to be, if you have to go back to this, you can look at it. The power would be n, which is 2, times number of years. Are we doing 10? Yeah. 2 times 10. Maybe I'll write this one out a little bit more. So $10,000. And then the inside parentheses, you're going to do 0.12 divided by 2, which is 0.06 plus 1. So it's going to be 1.06 raised to the 20th power. So 10,000 times, got to raise that to the 20th power. 3.207, and it goes on. I'm going to try to use all those numbers as I can. All right, and multiply that by 10,000, and we get 32,071.35. That's how much money you'd have. Of course, as it is after 10 years and doing the calculation twice per year. So this is kind of a more specific formula to use. The other one was very more general. The other one that we looked at before was only talking about annual. So I don't know if you noticed, but all the way back here, it's annual compound interest formula. So it's only for once a year. The other ones are for a very specific number of times per year it happens. So that should be enough to finish the rest of the notes for 7.4. Trying to see if any of these are tough to do, but I don't think so. There's only 3 more to do of that kind. And that will finish 7.4.